Hey, physics folks, let's take a look at balanced forces and force pairs and see what exactly is the difference between them, because they do have things in common, and so they can be kind of confusing. So here we go. Let's jump into balanced forces, which is something we have seen before. So let's take a look at an example to remind us. If we have a table and we have a book on top of the table, we know that gravity is pulling down on the book and it's not falling because there's a force on the book that is pushing upwards from the table. Physicists will call it the normal force. We can call it force from the table, no problem. It's like tomato, different words. But this is the force that is stopping it from falling. Now I want to think about another example. Well, actually, let me go ahead and label this one not moving. And let's go ahead and have some sort of crate that is falling. So it's got a downward velocity. And let's go ahead and give it some gravity. And let's consider air resistance. And so if these are equal, and I'll put a little kind of line like that, I think mathematicians do that to show that these are equal in length, because I don't have a ruler. If those are equal, then we're at terminal velocity, which means it's constant velocity. All right, now let's think about what do we have here. Balanced forces. All right, so I have my little cheat sheet out here. When you have balanced forces, there is no change in motion. Okay, so it either is over here, it's not moving, so it's not changing. But over here, it's got constant velocity. So it is moving, but it's not changing its motion. It's staying the same velocity, same direction, same speed, because the forces are balanced. All right, now let's see that those forces are equal in strength. And then forces are in opposite directions. Okay, and then, oh my goodness, I'm going to go ahead and put like a star on this next one. Drum roll, please. Forces that are balanced are on the same object. Okay, in my example, both of these forces up here are on the book. Down here, both of these forces are on the crate. Gravity's pulling it down and air resistance is pushing back up on the crate as it falls. So forces are on the same object. That is big. Okay. Now, when we think about forces that are on the same object, this also brings us to a good point. When forces are on the same object, they can be unbalanced. Okay, so if we had our gravity example where it's falling and we get a little bit of air resistance, okay, this would mean that it is speeding up. And I should indicate that it is moving downwards. Okay, so forces that are on the same object can be unbalanced. But when we're talking about balanced forces, those forces are on the same object. Okay, I'm actually going to rewrite this and take it away from here. Okay, and just to be clear, when forces are on the same object, they can be unbalanced. And there's an example of that. Okay. So balanced forces are forces that are acting on the same object. Now let's scroll over here and think about force pairs. All right, time for some art. Let's see. This is going to be a person that is pushing a car. Whoop, that got crooked. We'll just go ahead and leave this picture in instead of trying to redo it because it's not great. It is pretty bad. So this is going to be an example of a force pair. So the first force in this pair, because the word pair means we have two, the first force is going to be the force of the person on the car. Okay. Now the second force, and I'm going to indicate that these are the same size arrows. The second force in this pair is the force of the car on the person. What? The person's pushing the car. Well, if you push on a car, you can feel it. You feel pressure on your hands, and if you feel something, that means that something's pushing on you. So you push on the car, and then the car pushes back on you. This is something you've probably heard before, and maybe your brain's okay with it. But let's just go over some of the details about force pairs. When we have a force pair like this, motion can change or stay the same. So what does that mean? That means that it could speed up, it could slow down, it could be at constant velocity. All right, any of those could happen. Balanced forces, it's going to stay doing what it's doing. Force pairs, it could do any of those changes. All right, so some things that are similar. Forces are equal in strength. And forces are in opposite direction. Now let's go ahead and think about the star, the star, the star, the star. Each force in a force pair is on a different object. So that is different than in balanced forces, okay? So if we label these, this is force A and this is force B. Okay, force A is on the car, and force B is on the person. So that's how I know it's a force pair. They are on different objects, okay? We could talk specifically about the car, but when we talk about force pairs, our system includes two objects that are interacting with each other. And that brings us to what you're seeing in the simulation with gravity. So let's go ahead and, I don't even know which one blue is, probably that one. Okay. Earth and, I don't know, this is a sun color. Okay, Earth is in orbit around the sun. Excuse me. And so we know that when we usually talk about gravity, we talk about from the center of the object. So I'm going to draw that. Okay, this is the force of gravity. And specifically, it is going to be the sun on the earth. Okay, now, whenever you have a force, there is going to be a partner to make a force pair. Every force has a partner. And so this is the force of gravity. Where it's the earth on the sun. Okay, I'm going to indicate that I've tried to draw those the same size, and this is the part where your brain might not like it, and it might try to throw some information into the recycle bin because it doesn't fit into what we think about the universe. But the earth is pulling on the sun just as hard as the sun is pulling on the earth. Okay, gravity is no different than those other forces. If we have one force of gravity, so the sun's pulling on the earth, which we know it does to keep us in orbit around the sun, then we have a pair, meaning that the earth is pulling back on the sun with the same exact amount of force. Okay, now if you want to think about this, if what I'm saying also can apply here, that if the earth is pulling you down with a certain force of gravity, then I would say that you are also pulling up on the earth with the same force. And I don't know, a lot of people, they're like, nope, 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 nope. But let's see, going forward, let's see if we can make sense of that. Thinking about you pulling on the earth just as hard as it's pulling on you. Okay, get your notes down, balance forces and force pairs in your handout. Let me know if you have any questions, and let's keep moving through G3.